In this video, we'll describe the electrical potential energy of a pair of charged particles. Now, we've only so far talked about the potential energy of a uniform electric field distribution, so near a large charged plate or near two large charged plates. This is in some sense the more fundamental electric potential energy that we'd look at. The difficulty is that it's a little bit more complicated of a formula. Now, the analogy I would like to draw is that you first learn gravitational potential energy is mgy, just the mass times that little g, don't call it gravity, it's the gravitational field, times the height. And similarly, we just learned that in the case of a large plate, it's negative QEx. But the more general and correct formula is for gravitational potential energy minus g m1 m2 over r. And that's because there's a gravitational force that varies as you go outwards. The reason why you can use mgy is that the gravitational force is approximately constant over small distances compared to the radius of the Earth. Similarly, if the field is uniform, it's not changing, we can use the formula that's linear, it's QEx. Here, since the electric field really changes as it goes out from a charged particle, in the same sort of way it's KE over r squared, where the electric force decreases as 1 over r squared, you end up getting a similar result. Here you get that it's positive KE Q1 Q2 over r. Notice that this still has the same sort of form as the gravitational potential energy one. It's divided by the distance. It also has a change in the sign, where before mgy went from positive to negative g m1 m2 over r, and the formula for electric potential energy went from negative QEx to positive KE Q1 Q2 over r. And the other thing to note is that it has similar types of variables in the same spot. So capital G is a constant that describes how strong gravity is. K sub E is a constant that describes how strong electric stuff is. M1 and M2 are the two masses that are causing the gravitational potential energy, and Q1 and Q2 are the two charges that cause the electric potential energy.